We talk a lot about React, but we don't talk enough about the package that powers it, React DOM. If you're not already familiar, React DOM is the package that does most of what we think of when we talk about React. Not the component tree, but the actual rendering of it and putting it in your DOM. When you use a div inside of a React JSX return, that's not part of React at all. That's a calling to the React DOM package that has created all of these bindings for all these things that might exist in the browser. And we're not even talking about React Native yet. Let's be real, this stuff's kind of complex. So before we dive into the new package React Strict DOM, I want to give a brief overview with a couple diagrams so it's a bit easier to digest. So if you already know all about the React DOM, feel free to skip to the part where we're talking about the new stuff. But Strict DOM is interesting and complex enough that I want to make sure we have an overview of the fundamentals first. So let's get started. One of the easiest ways to think of a React app is as a bunch of little nodes. So we have app, which is our top level node for our application. App has some children. We'll say that this app has a first child of, or we'll call this top nav. And it also has another arrow, which is another subcomponent here of page content. We'll pretend this is the code for the app. Pretty common stuff. You've all written something like this before at your top level. You have the app as the top nav and a page content. Maybe instead of having these blank tags, you have HTML, open and closed. Maybe you wrap page content in a body. Lots of different things you can do. But for the sake of this example, we're going to pretend you have a normal HTML page and you don't need those tags. Top nav, we're going to pretend it's really boring. Page content, I want to actually draw out here though. Pretty simple component again. And this is getting mounted in the app as page content. React is thinking about all of these nodes. Within the React virtual DOM, which I should specify here, this is the React virtual DOM, we have this hierarchy, this tree. We have the app at the top, we have the child top nav, and the other child page content. These are different elements. Okay, technically the top nav should be in the body element. I'm going to change this to be main instead of body. Fair point. There. Shush. Anyways, this is a pretty typical React experience. But what comes out of this? I'll write the code first. I think that will make sense. I think we can all understand how this React app becomes this HTML in the end. This hopefully is somewhat clear to you. And if not, definitely go check out some deeper React tutorials, especially like the React docs. I want to make sure we understand at the very least that the result of this diagram and this React application we have here, that effectively this becomes that. This JavaScript and React going in results in this HTML going out. An important thing to note is that the only elements that actually exist within here are the ones that we have called that are real HTML. So these lowercase main and div and these things, these map to real HTML elements, whereas everything else is a virtual fake element that only exists within the React world. So you can have these open close like fragments, you can have named functions, and none of these things map to real elements in the DOM. They're just there in our virtual React world so we can compose and compartmentalize and reuse these pieces. If we were to try and diagram this the same way, it's not too hard. We have the HTML, we have the body, and then from body we have two directions. We have the nav div, and we have the main content. And within the main content is where we have everything else. So in here we have, once again, a straight down div. And this guy just has text content of hello world. Hopefully you guys can see how this HTML represents this tree and vice versa. The reason this is important is the actual thing that translates from here to here. That is the React DOM. So if I was to copy this guy, paste it there, copy this guy, paste it here, we can draw some important relationships here, where first and foremost, this kind of ties to here, but not really, because again, this doesn't render anything. So this isn't a hard tie. I'll mark that with the triple dots here, because this could be done via server rendering with Next. This could be done via having an existing HTML scaffold, and then you just mount React to a certain node. But there's going to be something on here that's like document.get element by ID for app or whatever. And then you call the React render code. Create root is a function from React DOM. Note, again, this is coming from React DOM because the ability for React to update your DOM comes from this package. So we create root using that. We find the root element that we want to bind to, and we call .render on the create root with our actual app. This is how most React apps are actually started. You'll often have this code hidden from you because it exists in something like Next.js, but this is where the HTML and the page in the React code that we're talking about get combined into one cohesive thing. So whichever element this is being bound to, that's how that happens. It's probably going to be body, not HTML, but you get the idea. And now for these other elements. These are going to be more direct ties. This one, I'm going to not do the dotted line because this one, once the root has been rendered, this is a deterministic relationship. These things are attached together. The top nav component renders this, and the page content component renders that. And we know that because if we look back here, we see what the page content renders and which React DOM elements it's binding to. But React DOM is how app gets bound, and then consequently, how the relationships between your React components and the HTML elements on your page form. Here's where things are going to start getting interesting though, because React DOM isn't the only way to render things with React. I have a whole video about this called React Wasn't Built for the Web, where I showcase a lot of the different things you can use. One quick example is React 3 Fiber. If you use React 3 Fiber, you'll know there aren't too many traditional HTML elements you're calling. We still call mesh, but a lot of these other things like box geometry, ambient light, spotlight, all of these different things we're calling instead, these come from React 3 Fiber bindings instead. This difference is important because React 3 Fiber isn't using the traditional React DOM package. It's an alternative to it. It's the thing that turns the React code into what you're trying to render and builds that relationship between the two. It's the translation between your React virtual DOM tree of components and what you actually render. This is even more so the case with React Native. Here's a pretty standard, recently initialized React Native application. And you'll notice here, we don't have divs, we don't have spans, we don't have any of the things we're used to. We're actually importing text in view. And yes, if I was to write text here, it's like, hello, and I didn't wrap this in a text, it would crash at runtime. It wouldn't work. If you're already React Native, this probably looks insane to you. Like, why are you importing this custom thing called view? Why not just use a div? Why do you need to wrap everything with text? It's not even span. Why not just use span? Why are we passing styles as an object to all of these things? What's going on here? Well, what's going on here is there isn't a traditional browser DOM on the other side. The way the React DOM package works is it binds every single thing you can reasonably do in the browser to a helper in React. So every potential lowercase HTML element you might use is accessible within React as long as you're using React DOM. But now if you're targeting a platform that isn't a traditional platform targeting the traditional web DOM, you can't just dump all of the things the web can do in and expect it to work. Hopefully you're starting to see where we're going here. The interesting piece is that these limited sets here, where you have to import the allowed pieces, instead of just calling whatever you want, wherever you want, as scary and big of a change as that is, it actually gives you a lot more control over what the developers can and can't do with your application. It also means you have really good control over those core primitives. You can build the exact building blocks you want and keep people from using Marquee, which, crazy enough, despite being deprecated, they can still use nowadays. I'm not saying that's a bad thing. I think that React DOM is the way most people use React for a reason. In fact, if I go to NPM trends, you will see the vast majority of React users are also using React DOM. These things are very, very closely knit, and there's a reason for that. Because usually when you're writing React, you're targeting the web, and usually when you're targeting the web, you're using React DOM as the connection between the browser and React. If we add in React Native for reference, big difference. React Native is nothing to be scoffed at. Like, these numbers are still insane. Getting 2 million installs a week for anything is nuts. When you compare that to the 22 plus million that React and React DOM are getting, it's a different world. So again, why are we talking about this? Well, I have to do one more important tangent, which is React Native for web. This might sound insane if you consider what I just showed here, where we can't use divs, we have to use views. We can't use spans, we have to use text. We have to use the provided pieces. Why would we ever want to use this for web? Wouldn't we want to try our best to avoid this and just use React DOM? Not everyone. Believe it or not, there's a lot of things you can do in standard HTML and in the standard DOM and browser that are probably not ideal and that you might not want to have, especially at a company with a lot of developers that might vary in experience. You might want to be sure nobody can make a span. You might want to be sure nobody can do a marquee in 2024. You might want to have a set of custom components that are your core building blocks and not want people to have access to the HTML outside of that. So when I'm discussing React Virtual DOM, imagine a line here. This line is the wall separating the React world from the things that actually get rendered. This is where React Virtual DOM lives. And if you wanted to control what things on the other side somebody has access to, this is the place for it. I think understanding the history of React Native Web and the goals that they had will make it a lot easier to understand the chaos going on here. The history of React Native for Web is fascinating. React Native for Web was started in 2015 by Nicholas Gallagher during the development of Twitter's progressive web app. It has evolved from a framework inspired by React Native into a mature and pragmatic compatibility layer between React DOM and React Native. React Native for Web is currently used in production web apps by companies, including Meta, Twitter, and Flipkart. One of these is not like the others. Anyways, software engineers from Meta, Expo, and elsewhere continue to contribute design and patches to the project. Developing a web compatibility layer for React Native involves balancing the needs of high-quality web apps with the value of the React Native API compatibility. There are instances where parts of the React Native API are co-opted to infer information that is necessary or beneficial to products running in web browsers. Other times, there are use cases that are not accommodated by the APIs provided, even when the information cannot be pragmatically incorporated into the existing React Native API design constraints. It still helps to inform which API changes are needed over the long term. The evolution of React Native now involves developers who work on React Native for Android, iOS, web, Windows, and Mac. We aim to help designers and developers with shared platform-agnostic React APIs that reduce the time to market for high-quality multi-platform products. So, there are a couple pieces here that I really want to dig into. First is that this started during development of Twitter's progressive web app. What does this link to? How we built Twitter Lite. For what it's worth, the Twitter Lite codebase is now the majority of how Twitter's components work. It's become the standard for the Twitter web experience. It is my understanding, and if anybody has a link to prove this right now, it'd be very helpful, that a huge reason why they chose React Native for Twitter, even though they're not using React Native anywhere else, they used it for the web app because they wanted to limit the set of things the developers had access to give a more controlled and consistent experience on the developer side and eventually as well on the user side. But how does using React Native achieve that? By giving you a strict subset of what the DOM can do that is defined by a team that puts a lot of effort in to make sure it's exact. This is a quote from Nicholas, who was the guy who started React Native for web at Twitter for their web app, despite not using React Native anywhere at Twitter at all. We just wanted a higher level API than raw DOM and predictable styles. Those are huge pieces there. So, something you might have noticed is how thin this line is between these things. When you make the page content component I showed before, you render the main directly, and then you render the div underneath it directly after. You don't really have a way to make sure divs always have the things you need, like accessibility. You have no way to make sure images are handled properly in all the ways you can render them. There are lots of different ways to do everything. And yes, theoretically, in your code base, you could forbade using divs or image tags and build your own custom thing that calls the DOM for you. We even see this in projects like Next that have lint rules that nudge you lightly in the direction of, hey, use our image component because the one built into the browser is a lot harder to work around. The distance between these sides and the size of the React Virtual DOM layer, very, very small. With the traditional React package, you're effectively calling React DOM, which calls the DOM directly. There's very little abstraction between these pieces. So if you want to have more control of that layering, you could build custom components for it, but now you have to deal with all the other platforms you might support in the future and developers just working around it and calling a div anyways and doing things wrong. The power of this system, and once you've built a strong abstraction here, when you build an actual, rather than just a line here, a wall, a gap between these two where you're picking what each side has access to, it might be harder to do something this wall doesn't account for. It's also hard to do something wrong if they've built in this way. Think of it almost like a super, super opinionated component library that you have to use for everything. There's a ton of benefits here. One of the big ones that got called out, as I hinted at earlier, is predictable styles. If you've worked with CSS in a big code base, you know that CSS is not predictable. In fact, cascading is often kind of evil. A lot of why StyleX was made was to help address this. If we go to the Thinking in StyleX page, deterministic resolution is a really important piece of why they built this. One of the specific goals they had is to keep things from affecting other things. Don't have a component that has a style that affects its children. The last style applied always wins. This makes life significantly easier. This combined with things like their focus on modularity and composability, it makes sense why having cascades affect everything underneath them. It's not the best behavior when you're building components, not pages. This difference is huge. A lot of how CSS and the DOM were built was the idea of a page that was static, that a server rendered, and when you need new data, you load a new page. These patterns are great in those environments where nothing's being reused, but that's not what's going on here. Once we're building components that are being reused across hundreds of pages and thousands of views you might not even be able to think of now, those behaviors kind of suck, which is why with React Native, they ignored all of that and went and did their own thing. And the thing they did turned out to be, in many ways, more maintainable on the website too, because all of these weird behaviors went away. Containers are limited to what they're defined to do. And if you have a child that you want to have behave a certain way, you tell that child to behave that way. You don't have a container that arrow selects certain subclasses to try and brute force certain patterns. None of that shit works at scale. That shit barely works in like small projects. Here's where we're starting to get into the new stuff. So anybody who's skipped to this part, hello, nice to see you. we're going to talk about a new DOM. When React Native was started, the team thought about web, the good parts, accessibility by default, flexbox versus floats, and removing cascading from styling. We tried to design our own thing to do that. That was bespoke and yet another thing to teach. Now we're looking for the best of both worlds with web compat. Good stuff. And that's what I'm seeing here too. I think this is the perfect way to transition to where we're going now, which is React Strict DOM. Meta just open sourced React Strict DOM, which aims to unify APIs between web and native to share as much code as possible. Before I go too much further, I want to disclose my personal bias. I don't love the idea of one code base being used for both web and mobile as an application developer. The reason for that is simply because web experiences and mobile experiences differ in a lot of ways. And I could believe you're writing one code base to make a good iPhone and Android app. But the way the web works and the way we interface with the web, even just the aspect ratio of the screen, is different enough that one code base, all these targets, still not in love with that pattern just yet. I'm getting more and more convinced, and as resources like this are created, I see the value there. But I'm not looking into React Strict DOM exclusively as a way to write my code once and have it run everywhere as an app developer. I'm kind of looking at it like that as a package developer. If these tools make it easier to write something like a style library that's reusable across everything, awesome. A+, really cool. But when I look at this as an app dev, I don't necessarily see a bunch of things that I'm rushing to go do to have one code base target everything. But it's still very interesting. So let's dig in. React Strict DOM is a subset of React DOM, Imperative DOM, and CSS that supports web and native targets. Very interesting. It sees itself as a subset of all of these things that already exist. But we're trying to pick the pieces that we can correctly assemble in the most reliable, resilient, and accessible ways. React Strict DOM is an experimental integration of React DOM and StyleX that aims to improve and standardize the development of styled React components for web and native. The goal of RSD is to improve the speed and efficiency of React development without compromising on performance, reliability, or quality. Building with RSD is helping teams at Meta ship features faster to more platforms with fewer engineers. To support native platforms, RSD builds on the design goals of the React DOM for Native proposal. By polyfilling a large number of standard APIs and by leveraging new web capabilities coming to React Native, such as DOM traversal and layout APIs, as well as a well-defined event loop processing model. React Native compatibility is a work in progress. Please see the compatibility for a detailed breakdown. Again, if you're an experienced existing React dev, this might be stressful to see. HTML.div, HTML.h1. It's a bit different. The reason for that is we're importing the HTML tag from React Strict DOM because we're not inferring a bunch of random stuff just by having the React DOM package anymore. We're explicitly doing the thing React Native did here because we explicitly want to make sure that we're calling that set of things that we've defined and allow. This is more things to write for sure. In the future, it's possible we have plugins that just do this part for you, but I think it really emphasizes the concept here where HTML is no longer a thing that's inferred because you have React DOM installed. Now HTML is a thing that's provided by this React package that you can consume, adopt, wrap, do whatever you want with. Another important part is that CSS is a shorthand for calling StyleX, as they mentioned before. You'll see that CSS and HTML both imported from React Strict DOM. It's a weird thought to import these existing browser standards from a thing named React so we can call a strict subset of them, but it gives you way more control. Again, especially at the scale these companies are working at. They want to make sure nobody's mounting some weird component or some weird HTML element in a way they're not necessarily supposed to. Here is the original RFC for this proposal, written by Nicholas back in 2022. This is the guy who originally made React Native for web, and now he is working on React full-time, it seems. Yeah, at Meta. Cool. He went from Twitter and building React Native for web at Twitter to working full-time at Facebook and Meta to build the future of how we render our React stuff. This is a proposal to incrementally reduce the API fragmentation faced by developers using React, target multiple platforms via code shared between native and web. The proposed cross-platform user interface APIs are a subset of existing web standards for DOM, CSS, and HTML, strict DOM. The proposed changes are overwhelmingly additive and do not require migration of existing React Native UI code. Deprecations are optional or follow-up work. Incremental progress can help to reduce the fragmentation between React Native and React DOM components, while the ability to run React DOM code with minor modifications on native is a longer-term goal. This is a very important piece here as well. It seems like one of the strict goals of this is to allow for component libraries to be written in one place and adopted in multiple places. Is it possible for me to import a package that has components defined in strict DOM into a project that isn't using strict DOM, that's using just the standard React DOM? Can I treat these as components and just render them in there? As someone who spent a good bit of time hopping between React for Web and React Native, I can tell you there's a lot of things that just come with the web that are both good and not necessarily good. That means that writing code in one place and expecting it to work in the other is far from a guarantee, and expecting the browser's standards to be applicable and even useful in many cases is also very far from a guarantee. Something that was learned with React Native for Web is just how useful an abstraction from the web can be for making more guarantees about how things work. And this project's going a little bit further, making this strict subset so strict that most of the behaviors you would reasonably want to encode are cross-compatible between not just the web, but also these mobile and other native platforms, where when you render a button, you're not rendering an HTML button, you're actually calling native primitives to do native stuff. There's a couple things Eli from the React team said in chat that I think are really useful here. One is this bit here. It's important to remember the React Native team's principle number one is that their top priority for React Native is to match the expectations people have for each platform. This is why React Native renders to platform primitives. As I said before, they don't render some magic React thing the same way you would in something like Flutter, where it's its own engine, nor are they just embedding a web browser inside of your app. They're actually calling a native button, a native touchable, native tab bars, or all the things that exist in the native platforms. And now they're just trying to make web match that a bit better. We value native look and feel over cross-platform consistency. But in order to make the web a more consistent platform, they can restrict parts so that you can transpile one piece of code between the two more reasonably. This is why Eli's comment here makes so much sense too. Do custom what should be custom, but don't duplicate what shouldn't. I think that philosophy is very apparent the more you read this RFC, the more you understand what they've built here. That's a weirdly familiar diagram. I swear I did not see this before I was working. Cool. So you have the React Native API. First layer, it has the element API. On the React Native side, these would all go to the React Native bindings. This isn't available yet. It's just meant to be an example. So I swear I didn't see this diagram until now. I'm not copying it. It is a little bit different from what I was drawing, but the Excala drawing is very much in tune with the channel. So React Native API has all of these pieces. It has the element API, the props API, the style API, the event API, and we have to have bindings for these to React Native as well as React Native for Web. So the element API has bindings to things like the animated flat list as well as create element, and these all in the React DOM get translated to the specific things that we're actually trying to render in the specific behavior, so we're trying to assign to those things. But when you call something from React Native, it has to be bound in the React Native for Web package and then point to the actual React DOM elements, which eventually become DOM elements underneath. This is a bit chaotic, but you get the idea that we call things in React Native that are then abstracted and call the right things on either native or web accordingly. This is the most complete and widely used shim, but comes with considerable DX and US costs on the web. The existing solution for targeting web with React Native is to use React Native for Web. React Native for Web is a user space library built on top of React DOM and native DOM APIs. It shims the React Native components and APIs on the web. The tooling for an existing React DOM app simply maps to the React Native export to React Native Web. Yes, as I said, this is just a hack that lets you use React Native on the web. It's a really powerful hack and lets you limit a lot of things, but it is also the most complete solution, and it's a widely used shim, but it comes with considerable DX and UX costs on the web. The shim must implement a large surface area of fragmented APIs, and it needs to modify standard APIs and objects like events to match the React Native's non-standard implementations. Yeah, there's a lot of little things like React Native does different. Like one really dumb example is in React Native, flex is a column instead of a row by default, which is a really good decision when you think about how flex would be used on mobile by default. But these defaults are different, and how events are processed are different, how things are queued are different, how styles collapse are different. All these things are different. The goal of React Strict DOM is to take the subset of things in the web that can and should work the same way and pull that out. So here we have the React Strict DOM diagram, where again, we have the React Strict DOM API has all of these pieces, and the React Strict DOM package for web is hilariously small, or 4 kilobytes instead of over 70, where it calls the React DOM set of things we actually want directly, and the event API does similar. And now we have a similar React Strict DOM shim to native. So instead of React Native being the direct target here and having a translation layer to go from React Native to web, we have the strict subset on top of all of these. And on one side, it gets translated to React Native, and on the other side, it gets translated to React DOM. But by building this abstraction, we're able to be stricter about the behaviors on all of these things and write the shims necessary for everything to behave similarly across all of these places. This diagram is really helping it click for me, seeing that we now have separate binding layers on both sides to go from the strict DOM abstraction to the right thing on both platforms, or all platforms, so to speak. In contrast, implementing a strict DOM subset in React Native shifts the weight of bridging native and web apps onto React Native, where it can be done most efficiently. Although React Native won't support all the features available on the web, it will support a greater expanded feature set relative to React Native today. On the web, we will only need to combine a React DOM with a white label CSS compiler, like StyleX. Again, the only layer needed now is to deal with styles, because the way styles work are not how anything works on any other platform. CSS is its own weird cursed thing, and I know I don't agree with everybody on it, but a lot of the things CSS does by default suck. And it's cool to see somebody as big as Meta committing to building these types of abstractions to try and push away all the problems they deal with there. It's actually hilarious how close this code is to what they ended up with, being that it's 2 years old, but shows they were committed. Here's an example of a VStack panel component that has events for pointer down and pointer up, as well as an html.div with children, onClick, refs, styles, etc. But wait, how are we going to render the html.div on something that isn't HTML? These are all the elements that exist in HTML that are accessible in both places. But we don't have an article in React Native, much less in iOS or Android. So we just bind that to a view. Aside, we bind to a view. Block quote, we bind to text. BR, we bind to text. Button, we bind to pressable. Code, we bind to text. Etc., etc. We have bindings for all of these default HTML elements we want to support to a corresponding-ish existing native package for React Native. This is really, really interesting. Even the pressable is animated by default because we export an animated pressable, assuming we wrap this somewhere. Yeah, if native component is pressable, then native component equals animated pressable. Export function create strict DOM component. Component extracted forward ref. Thought we were done with forward ref, guys. What happened? How do y'all start using that? I thought we were over with that. Anyways, bunch of crazy abstracted code that's goal is to make sure you render the right component depending on which environment you're in, and that it's close enough to the thing you're trying to render so the behavior is roughly the same. Looks is not all that matters. Complex interactions matter more than styling. That's actually a really good point here. Something like a tooltip would work really well with this environment where we want things that behave the right way in many places, even if they look slightly different in all of them. As per usual, Dan's perspective on the new thing is actually really useful. This looks like a spiritual successor to React Native for web, but approached from the other direction. Web APIs won, so React Native is building support for a strict subset. Essentially, you'll be able to render a div in React Native, compat table reflecting current state. This was the compatibility doc that we were just looking at before. The exciting part is that it's almost zero abstraction on the web. Stylix generates real CSS classes at compile time. Strict tags are single component wrappers. On the native side, there are shims that massage the props. But hopefully with time, React Native will add direct built-in support. The non-technical exciting part is the blink and you will miss it acknowledgement in the README that Meta is actually using this, which makes this the first cross-platform React solution targeting both web and native with the same components that Meta is directly investing into. That's a really big point to call out here. Previously, Meta hasn't invested in these specific multi-platform component solutions because they build the right component for web, the right component for mobile, the right component for VR. And React Native is mostly a tool for us to make things using the same mindset. But now it's just not just the mindset, it's the actual code itself being shareable. React Native Web's approach was to polyfill the React Native APIs on the web, and it has a bunch of flaws that aren't fixable. Too thick runtimes are abstractions on the web. Yeah, I understand. React Strict DOM's approach is to polyfill good web APIs on React Native instead, and to rely on the ongoing effort of actually building those APIs into React Native. So it's rather than taking the bad parts of the web and throwing them away, it's more taking the good parts of the web and bringing them to React Native by making the subset that fits everything together well. I don't envy anyone trying to explain to iOS only or Android only devs that the HTML.div they're seeing is actually native. Yeah, this has already been a problem. See people tagging me in, all legends, for making sure I saw this. It's a very, very interesting development. And as per usual, Dan put it way better than I could. So hopefully this was helpful in building your understanding of what the hell is going on here. Because this is one of the most interesting developments in the React world that most people aren't going to touch or play with anytime soon, if ever at all. It's different. I'm actually really excited to see where it goes. One last check with Naman as well as Eli to make sure I didn't miss anything too important. Currently, React Native only makes it easy to share business logic or data loading with web, but not UI. So much UI is often the same. Let's work on sharing it. React Strict DOM is only one part of our research into this. Ooh boy, those are some big promises. Proposal to formalize the steps that React Native follows to perform tasks on the JavaScript thread and how that work is synchronized with rendering work in the host platform. Ooh boy. This could be its own video from what I know and what I don't know and what I have to research. If you're already familiar with the event loop in JavaScript, you have one thread that does everything. If you want to have something that's processing background data that a user submitted, but it's also rendering the page component content, this model doesn't work great. And a lot of why people think React is slow is because the thing that updates the web page is being blocked by things going on elsewhere. Otherwise. And if we build a event loop processing model that guarantees the view changes are happening in the correct order and as aggressively as they can, this is really exciting stuff. A big part of why this matters is the rendering work being done on each platform is so fundamentally different that making sure events are synced properly and the order of events is correct when you're using the same code in all these places, it sucks. It's a silly example, but if we go to the jQuery 4.0 blog post, I talked about this in my jQuery 4 video. Just one dumb example. jQuery orders the focus events as focus out first, then blur, then focus in, then focus. The previous W3C standard was focus out, then focus in, then blur, then focus. But every browser ignored that for some reason. It went with blur, then focus out, then focus in. Eventually, the W3C caved because everyone was using a different behavior and they overrode the spec in 2023. But the fact that there were these 3 different orders these events could be in is terrifying. And the fact that you might have to think about which one happens in which browser for which reason at which time is horrifying. Now multiply that by itself and add an exponent on top for shit. When you're dealing with Android and iOS and Windows and Mac and virtual reality and the web, which event's going to hit first? Good luck, have fun. Having more well-defined processing for all of these things is increasingly essential. The core thing to notice here is that this code can run in both React for web and React Native. This is a big deal because measure in window and these types of references just don't exist in React Native. I went to hell and back trying to figure out how wide something is on a given platform. But these web standard APIs not only are now accessible inside of React Native, where they have to have crazy native shims built, but they actually occur and run in the same order with roughly the same experience across these platforms. So you can call something like measure in window in a layout effect, which is running synchronously instead of asynchronously, and know the behaviors are going to be exactly the same across these platforms. That's huge. You even do stupid things like set the state of the value that you get here and have this come back the same way in roughly the same time. Instead of having multiple updates triggering Flickr, this will block and then render once we have it. Like these types of things were not possible before. As silly and simple as they seem, you couldn't really write code one time that had anything to do with these behaviors and have it rerun other places. If you were just doing Axios data fetches with React Query, this code would have been reusable. But as soon as you're doing anything that has to do with the platform itself, that's where things start to fall apart. And that's why rebuilding the event loop, rebuilding the DOM access layer, rebuilding these things is so useful, because it's trying to make an abstraction that works for everything, not just your styles and certainly not just your use queries, but for all of the glue code we spend our time in to try and make these things work properly together. If this was some random startup trying this right now, I would probably be laughing at them. But it's not. It's a big company that's shipping this in production already. And it's not just any big company. It's the company that brought us React and React Native already. This is a bold research project. I'm very excited to see where it goes. The main motivation for this proposal is to fix a series of problems in React Native that prevent it from implementing the React programming model correctly. The programming model defines a series of abstractions and assumptions that developers can rely on to build applications, independently of the platform they are targeting. If you look at the React documentation, everything under the React package, not in React DOM, should work the same way across platforms. But that's not the case for hooks like useLayoutEffect. UseLayoutEffect is a version of UseEffect that fires before the browser repaints the screen. Forgiving their mention of the browser, in React Native, UseLayoutEffect is not guaranteed to run before repainting. Important call out. Call UseLayoutEffect to perform the layout measurement before the browser repaints the screen. In React Native, layout effects can fire before layout information has been computed. So accessing layout information can provide stale or even incorrect data. These are all the types of things you don't think about until you've had these problems, and then they suck and are impossible to work with and use. The main goal of this hook is to allow multi-pass renders without causing UI thrash, and this goal is not accomplished in React Native with its current semantics. Another important motivation for this proposal is to increase alignment with the web platform. Again, they're trying to make these things that are useful in the web accessible in these other places. Oh, one more important piece they called out here is by having these reliable event loop behaviors, they're able to make optimizations they couldn't otherwise. If these things behave differently and people build around those assumptions in these other places, they're probably screwed. And now trying to optimize that with something like React Compiler is not as viable if these behaviors are so different, which is why I'm so excited to see what they're working on here. This feels like its own massive rabbit hole I could go down for a very long time. I want to focus on the strict DOM, but y'all should let me know in the comments if you want to hear more about the new React event loop, which seems to be increasingly a thing going forward. Let's give Eli a quick zoom in on this message to make sure it's clear to people that none of this is big things the React team is promising. This is not the same tier as something like server components and all the things we heard about in the React Labs post, where all of that is work they're committed to not just doing, but seeing through to completion. This is them trying new things to figure out what does or doesn't work, and including us in the process more than usual, which is awesome. Because not only is the React team open sourcing these things, sharing their RFCs, and bringing us into the process, we have the person helping run a lot of the team in my chat, giving us tons of useful information as we film. That's surreal. Having this level of involvement from the React team when they're this early on something is really, really cool. And I wanted to make sure we called that out for what it is because of both how rare it is and how awesome it is. This is the equivalent to stage 1 of TC38. Not even TC39. Well, cool. Yeah, huge shout out to Eli. Huge shout out to Naman, who I'm sure has sent something somewhat recently. Yeah, here he is, correcting me about use effect and use layout effect. Absolute legends. Dope to have them here. It's so cool to see and learn more about how Facebook and Meta are thinking about these technologies and the things that they've built. Huge shout out to the team. Huge shout out to everyone involved building and sharing this because it is actually really exciting. I know the meme is that we just talk about React all the time, but there is no other framework doing this level of research on not just the web, but how we build as a whole. Let me know what you guys think because this was a very interesting project and I'm definitely going to be talking about it more in the future. But until next time, peace nerds.